Hey there, everyone. Today we are going to do part one of the notes about nature of science. So before we jump into it, nature of science is a phrase that you probably haven't heard before. But basically, these notes, part one and two, are going to be all about what is science? What makes science different from other things? How can you tell if something is scientific or not? Which is really important as we're starting on a science class this year. So today we're going to look at part one. What is science? There's actually 5 characteristics of science we're going to look at in detail, and you'll have to know what all 5 of those are. Before we get to the specifics, here's a little background. So if someone asked you, what's the purpose of science? Why does it exist? What do we do with it? In short, the purpose of science is to try to explain the world around us. That's it. There are often lots of good things that come of that and good side breakthroughs and discoveries that affect our lives. But science by itself is just trying to understand the world, which gives us more information. And we believe that that makes our life better the more we know. The goal of science is going to change depending on what branch of science you're looking at. So, for example, biology is going to have totally different goals than astronomy and all the other different branches. But in general, we are trying to come up with the best explanation for the world and the universe around us that we can. And the belief of science is that that makes our life better by knowing more. So here we go. This is the most important part of the notes today. What makes science special? What makes it different? How can you tell if something is science or is not science? Because there's lots of times where people will probably try to trick you with something that looks like science, but it doesn't meet all of these criteria. So on the screen, you can see 5 characteristics of science. So those are 5 things that are true of science, but to be considered scientific, something has to have all 5. 4 out of 5 is not good enough. 3 out of 5 is not good enough. You have to have all 5. So if it is science, it's tentative, predictable, observable, testable, and falsifiable. You need all 5. So now let's go through and look at those one at a time. First is tentative. Science is tentative. If you've heard that word before, usually people talk about it in terms of like, oh, I've got tentative plans to see a movie or something like that. It means, these are my plans, but they might change if something else happens. It means the same thing with science. So by that, I mean that explanations, things like theories, hypotheses, even scientific laws can all change. And I'm going to try to convince you that that is a good thing that it can change. Because when we get new information through new technology, new evidence, maybe we just didn't look in the right place or look the right way before. When we get some kind of new evidence, we can change what we think, which is a good thing. Because as you've grown and learned more and your abilities have increased, your understanding of the world has changed a lot from when you were a little kid. And that's good. You should have a better understanding of the world today than you did when you were really little. Same thing with science. The best scientific minds in the world once believed that the world was flat. And then we got more evidence, and now we know it's a giant sphere. They also thought at one point that the Earth was the center of the solar system, if not the center of the universe. Well, we got new information, and now we have a better picture, and we have changed. That is a good thing. If science wasn't tentative, we would have to get everything 100% right the first time, and we could never build on ideas, and we could never add new information, which means we would be wrong about so many things. So science can change, but that's good. At the same time, science is also reliable. Now, that's a little confusing, but all I mean is science can change, but in order to change it, we need lots of information. You need some really new convincing evidence or really new technology that changes the way we can collect data, something like that. But that doesn't happen all the time. There are certain big ideas in science that could change, but they probably won't because we have so much evidence to support them. like gravity, is not going anywhere. We have tons of evidence that supports the fact that gravity is still going to be active tomorrow. So you don't have to worry about that. Another little spin-off of this idea is in science, you cannot 100% prove something. Science can never 100% prove something to be true. So if someone really knows about science, they're not going to say, oh, science has proven that blah, 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 because some new piece of evidence could come along and change things that we thought were true. And that has happened. Well, like the Earth is no longer flat. The Earth is no longer the center of the solar system. People thought those things would always be true. The thing is, you don't know what new evidence is out there. What new evidence is waiting for us to discover it that will completely change the way we think? We don't know, because we don't know what we don't know. That's another big idea in science. You don't know what you don't know. So science is still reliable. You can still trust the conclusions of science, but it is possible for them to change. So those two ideas kind of balance each other out. The next idea of science, so this is the second characteristic, is predictable. Science is predictable. And that means that conclusions from science have to be able to predict events or situations that are going to occur in the future. If something claims to make a prediction but can't explain or can't actually make that prediction, or never makes that prediction correctly, it's not scientific. So back to the gravity example, gravity will predict what's going to happen if you take an object and you drop it. It's going to predict the path that it'll take, the time that it'll take to fall, and you can learn all about that stuff in physics. But the point is, it makes an accurate prediction. Just like I can predict that Homer Simpson is still going to like donuts tomorrow. Certain things like if you know astrology, like reading what's going to happen to you based on your star signs and stuff, that's not science, because if you look at those predictions, they don't always come true. And they're often written so vaguely that you feel like they're coming true, but it's not predicting things in the same way that science is. Next, science is observable. This is a pretty easy one, but that just means that the data that is collected in science is not just something that we think about, or like, oh, the way we think things should be. It's actually data that we can collect and observe. The only thing that makes that term slightly confusing is by observe, we don't always mean observe with the human eye. We can use our physical senses, but we can also use extensions of those senses like telescopes, microscopes, satellites, mass spectrometers, all kinds of different devices, because not everything in science is big enough or small enough or happening slow enough for us to see, but it still counts as an observation if we use one of those technologies to extend our senses. Next, science is testable. That means you can set up a controlled experiment to test a claim that you're making in science. If someone makes a claim, but there's no experiment that you could do to set it up to see if that claim is true or false, it's not a scientific claim. Science has to be testable. Next week, we're going to talk all about experimental design and graphing and how to make experiments and all that. But for now, we'll just leave it at science is testable. Next, this is a word you might not have seen before. Science is falsifiable. So that's different than false. I'm not saying science is false. I'm saying it is falsifiable. So that means it has the potential to be proven false. I said earlier that you can never prove something to be 100% true. Well, you can prove something to be false. And I'll show you an example in a slide or two after we go through this. But to be considered a scientific idea or a scientific claim, it has to be possible that it could be proven false by some new evidence. Doesn't mean that it ever has to actually be proven false, but it could be if that evidence were ever uncovered. Another idea in the second bullet point there is the idea that science is not confirmatory. That means that the best science is not done when you're trying to prove a claim to be true. You're actually trying to prove a claim to be false. And if you do tons of experiments, you collect tons of data, and you cannot prove it false, that means that you must support that claim. So here is an example of that. I believe all swans are white. To show it is right, or to show that I'm right, it's easy for me to look for examples of white swans. That would be an example of confirmatory science, or trying to prove myself right. So I could go all over the world looking for white swans. I could find 100 white swans, 1,000 white swans, 1,000,000 white swans, but I haven't proven, I cannot prove 100% that all swans are white. I can get lots of evidence that supports that. However, if I was trying to prove myself wrong, which is a better approach to science, how many swans that are not white do I have to find? Just one. And yes, of course, there is such a thing as a black swan. So to figure out if that claim was true, it's actually a whole lot better to try to prove it false. And if you can, you know it's false. You can never prove that it's 100% true. So to recap all of this, if it is science or scientific, it has to have all 5 characteristics. So if you ever come across an idea that you're not sure if it's scientifically supported, or you're not sure if it's accurate, all you have to do is ask, is it tentative? Is it predictable? Is it observable? Is it testable? Is it falsifiable? Only if you say yes to all 5 of those can it be considered science. If you said no to even one, it does not count as science. That means science is different than a lot of other things. A lot of people find it easier to just sort of like go with their gut, or like try to reason through things, just thinking about how they think it should be. But science is a whole lot more rigorous. That means it's a whole lot more difficult sometimes. That means it's slower sometimes, because you have to meet all those criteria. But that also means that the conclusions we get with science are oftentimes a whole lot more reliable, because we've gone through all those steps. So that is the end of part 1. I'll see you in the next video for part 2, where we're going to go through some important terms and definitions that you're going to come across this year, and also in the future as you continue to study science. So it's been fun. I'll see you next time.